Okay, so this is part one of what is shell method. In this first part, we are gonna explain what is the shell method. So as you can see here, shell method is a method used to calculate the volume when a curve is revolved about a straight line by using cylindrical shells parallel to the axis of revolution. This method is different from the previously this method, where this shell method uses cylindrical shells instead of circular discs, which is the disc method. So as for the formula, in the shell method, you are actually integrating the surface area of the cylindrical shell to get the volume of revolution. This formula for the surface area of the cylindrical shell is 2 pi radius times height. So for the shell method, we are integrating 2 pi radius, which is r, height with respect to r. So let's proceed to part 2, shall we? Okay, so in part 2, we're going to have this simple example of a question where the shell method is used. In this particular question, we are needed to find the volume of revolution when the curve y equals to x squared is revolved around the y-axis from x equals to 3 to x equals to 5. So, as we recall from the previous part, the formula for the shell method is integrate 2 pi radius height with respect to r. So here it goes. We're going to integrate the limit, which is 3 to 5. As for the radius, if you try to imagine this area revolving around the y-axis, you'll realize that the radius is actually x. So x. And in the same way for the radius, if you try to imagine this area being revolved around the y-axis, you'll realize that the height is actually the y value, which is x squared. And since we are revolving this around the y-axis, we are integrating it with respect to x and vice versa. Since 2 pi is a constant, we can take it out. Multiply this in. I'm sorry, this was supposed to be an x squared. Multiply this in, you get an x cubed. Dx. And now we integrate this, which is 2 pi x to the power of 4 over 4, 3 to 5. And the next step would be we have to expand this, which is pi 5 to the power of 4 over 4 minus 3 to the power of 4 over 4. If you calculate this, you'll get the value to be 136. Multiply this in and you get the volume of revolution, which is 272 pi units cubed. However, the question isn't always as straightforward as our first example. We'll come to our next case in part 3. So in part 3, we are going to explore a different scenario where the axis of revolution is no longer the y-axis nor the x-axis, but it is the vertical line x equals to 2. There are many methods to solving a question like this, but in my opinion, I think that this method will prove to be the simplest. In this graph, I have moved this curve, this entire curve, to the left by 2 units, thus making the equation y equals to x plus 2 squared. And if I revolve this area bounded by the curve and the x-axis at x equals to 1 and x equals to 3 around the y-axis, the volume of revolution that I would get would be exactly the same as if I revolve this area around the vertical line x equals to 2. So to solve this question, now we can just apply the formula as we did with the previous questions. Volume equals to integrate. The limit would be 1 to 3, which is 1, which is 3 minus 2, 3, which is 5 minus 2. Pi, the radius, which is x, and the height, which is y, which is equals to x plus 2 squared. And since we're revolving this around the y-axis, we're integrating this with respect to x. And once again, we can take 2 pi out since it's a constant. And if you work this out, you'll get x cubed plus 4x squared plus 4x. And now we can just integrate this. X to the power of 4 over 4 plus 4x cubed over 3 plus 4x squared over 2 from 1 to 3. And now we just have to expand this. Now, if you work this out, you'll get 2 pi 212 over 3. And the volume of revolution would be 424 over 3 pi unit cube. And that's our video.